Hi, I am Siti Khalijah. I'm teaching engineer for planning and scheduling course in the Faculty of Civil Engineering and Built Environment, Universiti Tun Hussein on Malaysia. Okay, in this session, I would like to share the topic of Program Evaluation and Review Technique, which is known as PERT. Okay, at the end of this session, I hope you can calculate the probability of achieving project completion on time using the PERT techniques. Okay, in this session, I will share some introduction to PERT and how to calculate using PERT. As an introduction, PERT is actually one of the scheduling methods that can be used other than the Gantt chart and CPM. It was introduced around 1958 in the military project. For some projects like military and space shuttle, it is essential to have a tool for evaluating the likelihood of achieving project completion on time. Even the PERT is rarely being used in a construction project, it is good for us to explore as the construction projects so are confronted with uncertainty in quantity and productivity. So in PERT, it is used 3-time estimate for each activities, which are optimistic duration, pessimistic duration, and most likely duration. Optimistic duration is estimate which presumes that everything involved in the performance of the work goes well. It is the best case scenario for the activity. A pessimistic duration is estimate assuming that almost everything involved in performance of the work goes poorly, which means it is in a low productivity. And the third estimate is the most likely duration, which anticipates the amount of the time where the activity will require most of the time if the activity is repeated many times. Means that for normal conditions, the most likely time is being used. But remember, it is not an average of the optimistic and pessimistic duration. If we refer to the figure, the scheduler should understand that the occurrence of possible pessimistic durations is not very likely. Here are some of the examples of PERT diagram, where in the diagram all the possible durations is being used. Just for note, the duration used in calculation of CPM and the Gantt chart is referred to the most likely duration. Okay, from the three estimate duration, we could calculate the expected time by using this formula. Standard deviation time and variation for each critical activity. Okay, basically, there are three main steps when determining the PERT estimate. The step are, first, we have to determine optimistic time, pessimistic time, and the most likely time for every activity along the critical path. Okay, and then we have to calculate the total, the expected time, variance, and the standard deviation for each activity. And lastly, we will calculate the probability. Here I give some example for calculation using PERT. Okay, in this project, the critical path is identified as shown in following table. We have to calculate the probability of project could finish before day 47. And second, the probability of project finish at the end of day 50. Third, the duration that project can finish at 90% of probability. And last one, the duration range using two standard deviations. Okay, I would like to remind that PERT calculation is only use a critical activity. So if you have one complete project, you have to calculate the durations using a CPM method and identify the critical activities. Then from that, you can list down all the critical activities and determine the optimistic time, most likely time, and pessimistic time for each critical activities. Okay. What we have to do is we have to calculate the expected time. So for the expected time, the formula is TO plus 4TM plus TP divided by 6. That is for calculation of expected time. So expected time for activity B is 14.33. Activity D is 11.66. Activity E 15. And activity F is 7.66 days. Then calculate the standard deviation by using a formula of pessimistic time minus optimistic time divided by 6. So the value of standard deviation for activity B is 1. Activity D is 1.33. Activity E is 1.33. And activity F is 1.0. Okay, and then calculate the variance, where the variance is equal to standard deviation power of 2. So here is 1.77, 1.77, and last for activity F is 1. Okay, so from that, calculate the total expected time, which is a summary of all expected time. So for this example, the total expected time is 48.65. Then the variance, the summary of variance is 5.44. Okay, from this value, we want to calculate first probability the project could finish before day 47. So the deviation Z is TS minus TE divided by standard deviation. Okay, So now we have the variance for total expected time 48.65. Okay, so the standard deviation for the total expected time is variance of total expected time sub power of 2, which is equal to 5.44, which give 2.33. So the variance, the standard deviation for the whole total expected time is 2.33. So now come back to the calculation. So we want the probability project finish before day 47. It means at the end of day 46. So the TS must be on 46. TE is 48.5 divided by 2.33. So here you will get 1.13. Okay, so from this value, we must refer to the normal probability table. If you have the negative probability table, you can just directly use the value of 1.13. So if not, you can use the normal probability table. Can look at the value of 1.1, 1.13. It is 0.8708. So from that value, the probability of project could finish before 47 days is 1 minus 0.8708 equal to 0.1292, which is the probability is 12.92%. That is for the first question. And then for the second question, probability the project can finish at the end of day 50. Okay, at the end of day 50, which means the day 50 is included. So the Z is TS minus TE divided by sigma TE. So here is 50 minus 48.65 divided by 2.33. You will get 0.58. So by referring to the probability table, 0.58, okay, 0.58, 0.7190. So the probability project could finish at the end of day 50 is 0.7190, which is equivalent to 70.90%. That is how to calculate probability of project finish before day 47 and before at the end of day 50. Okay, the following question is the duration that project can finish at 90% probability. So by using the same formula, okay, this formula, we could calculate the duration at the 90% probability. Okay, it is desired to determine the time duration for reaching event at 90% probability. So for this probability, it is necessary to find the corresponding Z value. The corresponding Z value is 1.28, which 0.8997 is the closest of probability value. So then the value of TS can be found by substituting the known value of TE and Z as this formula. So 2.33 times 1.28 plus 48.65, which is equal to 51.63 days. So at 90% of probability, the project could complete with 51.63 days. Okay, now we want to get the duration range using two standard deviation. So what is meant by two standard deviation, one standard deviation? Okay, one standard deviation is equal to 68.3% of probability. Two standard deviation equal to 95% of probability, and 3 standard deviation means that 99% of probability. So this one is referred to the standard deviation. Okay, this is referred to 1 standard deviation. Okay, this is 2 standard deviation. So for that topic, you have to study on statistical model. Okay, so for 2 standard deviation, it means that at the 95.5% of confidence level. So how to calculate the range, this range, the lower range and upper range of durations. Okay, we know that our standard deviation, okay, so this is activity. Okay, standard deviation, which is ours, and then we get the range, lower range and upper range. Okay, so how to calculate the lower range and upper range? Okay, so we have activity B, D, E, and F. Okay, the standard deviation is 1.33, 1.33. Sorry. This one is 1.0. Okay, so to calculate the lower range, what you have to do is the expected time minus 2 for 2 standard deviation times standard deviation. So this one you get lower range. For upper range, total expected time plus 2 standard deviation. So this one you get upper range. Okay, example. For activity B, the total expected time is 14.33 days minus 2 standard deviation. So it means that it is equal to 12.33. Okay, so for activity D, it is 11.66 minus 2 times 1.33, which give 9.00. Okay, for activity B, the total expected time is 15 minus 2.66, which give 12.3, and the last one 7.66, the total expected time, minus 2 times 1, which give 5.00. So that is for lower range. For upper range, 14.33 plus 2 standard deviation. So for activity B, it gives the value of 16.33. For activity D, 11.66 plus 2 times 1.33, which give the value of 14.32. For activities E, 15 plus 2 times 1.33, which give the value of 17.66. And activity F, 7.66 plus 2 times 1, give the value of 9.66. So that is the range, the duration range by using 2 standard deviations. Okay, so this is the lower range and the upper range of duration for each critical activity. Okay, I think that's all for this session. I hope this will benefit you in calculating the PERT, and I hope to see you soon again next